For example, for an object at the end of a vertical spring is stretched 4 centimeters beyond its rest position. So rest position 0, we pulled down on this 4 centimeters below rest position, and it's released. So if you imagine how a spring works, if you have it and you pull it down and you let go, it's going to do like that. It's going to be kind of bouncing up and down. Okay. See figure 5. Note the downward direction is positive. Okay, so as you can see, this is marked 0. That's marked positive 4. So downward is positive. Above 4 would be negative 4. So it's kind of a weird scenario here, but that's how it's set up. Its position at time t is s equals f of t equals 4 cosine of t. So let's just imagine t equals 0. Remember from trigonometry, cosine of 0 is equal to 1. 4 times 1 is 4. So its initial position is right there at 4 below 0. Find the velocity at time t. Use it to analyze the motion of the object. So if this is the position function, 4 cosine of t, how do we find the velocity at time t?
Find the derivative.
The derivative of position is velocity every single time. So we know that velocity function v of t is simply going to be f prime of t. And you can see f prime of t is just a basic trig function, cosine of t being multiplied by constant 4. Constants have no bearing on derivatives, so the derivative of cosine is negative sine of t. And then the 4 just comes along for the right, so negative 4 sine of t is going to be the velocity function of the object. So imagine at 0, what's the sine of 0?
Times 0.
What's the sine of 0?
Oh, okay, so what's it times? Sine of 0 is 0.
0, and 0 times negative 4 is 0, right? So its initial velocity is 0. When we let go of it, the moment that we let go of it, it's 0. We're not like flinging it up or anything. We're just like letting go of it. All right? So, you know, and as time changes, velocity is going to be positive or negative, you know, going up or down. All right? So, now, it says to analyze the motion of the object. So the best way to analyze this would be to take a look at the graph of it, kind of see what's going on here. And as far as analysis is concerned, you're basically just going to describe the motion of the object. It's speeding up, it's slowing down, it goes this far, this kind of stuff. That is weird. All right. Y equals, I'm going to type in negative 4 sine of x because my calculator doesn't understand t. I'm going to make sure my mode is in radians, not degrees. I'm going to go to my window. I'm going to start at x min of 0. Why would I start at 0?
Say what?
Released at time equals 0. Alright, so that's the beginning of the problem, 0 seconds. And let's go x max 10 is fine probably, we'll see. If we don't get enough information, we'll make that bigger. What do we know about the sine of x or graph? What's the biggest sine of x can be? Going back to trigonometry. Sine of x fluctuates between two numbers. Negative 1 and 1. So if I'm multiplying that by negative 4, we're going to be between negative 4 and 4, right? I'm going to go negative 4.5 to 4.5 because I like to see the tops and bottoms. And scale of 1's fine. If I hit graph, whoa, we can see there's the motion of the object. Again, that graph is the graph of velocity.
That's awesome.
All right. If I were to overlap that with the position function, 4 cosine of x. Anytime you get a function that represents stuff, it's helpful sometimes to look at those graphs. The red graph represents where the spring is, where the object is, and the blue function represents how fast it's going.
It's a mirror.
It's kind of they're the same graph. If you remember the sine and cosine always make the same graph. They're just phase shifted from one another. All right. So if you imagine here, the initial position is 4. That's 4 below, right? And then it gets all the way to 4 above, 4 below, 4 above. It's kind of going up and down. That's what's happening with the red graph. Now look at the blue graph. It starts off when it's at its maximum spot, 4 below the 0 value. It's not moving at all, right? It's going its fastest when the spring is in the middle at 0. Okay, that's a negative speed, but negative 4, so it's going up. Because again, remember, up is negative in this one, right? It's going up through the middle at its fastest speed. And then after it goes to the middle, notice it starts slowing down. It has a velocity of 0 again when the spring reaches the top. And then it's speeding up again to the fastest speed possible, going downward at the middle, and then it's back to a velocity of 0 at the bottom, where it's at the bottom again. It's kind of a weird thing where it's at the bottom and the top upside down. But so what's happening is the spring is reaching its maximum speed at the middle. The spring is stopping at the top and the bottom, or the object is, right? So that makes sense, right? Because if it gets to the bottom and stops, it's going to go back to the top and stop, and bottom stop, and so on. So the velocity is stopping at the bottom and top. It's hitting its maximum speed right there in the middle, though. Make sense?
Yeah.
Right. So as far as an analysis is concerned, we just basically write that in words. The spring has maximum velocity when s equals 0, and 0 velocity when s equals -4 or +4. Okay. That's an analysis of the motion of the object. So when you're analyzing motion, you want to analyze it based on velocity and also position. So to graph both of them on the same graph, your calculator is very nice with the colored graphs so you can see different colors to represent things. Just when you're interpreting that graph, remember what each thing is and relate the velocity to the position in some way, shape, or form. That's what an analysis is. That's what I'm looking for in a problem like that. I want to say there might be 1 or 2 homework problems that have that type of analysis thing on it. And again, I just want to make sure you have a good grasp on what everything in the problem's talking about. You're not going to have the same answers to the book or each other or whatever. Just give me some sentence there that tells me you understand how the velocity and position relate to one another.